So we were having this discussion about discrete and continuous that totally derailed actual forward progress. Rather enjoyed your relativity presentation recently on Demystify. But so in this instance I have some discrete elements where there's a capacitor, an inductor, a capacitor, inductor, a capacitor, inductor, and these are just a static grid in space. But what I could have is a field with a displacement, that the displacement moves from one place to another. Not really displacement, this is a charge potential. This is like positive or negative electric potential where the moving field is a magnetic. It would actually have a circular structure around it, you know, like this. That gives it the momentum direction of where to go. But these fields would be only existing in a location in space for a very short time. So they could be created in a short time and then taken back out. There's no way that this could support being a galactic scale wave because the time present doesn't allow it. In the case of a more static waveform, because this would be like a photon propagating, you would have something like this, where once they reach where they're going to go, they end up bouncing back. So you have these oscillations that are just localized entangled things. The three quarks end up out of phase, so there's a magnetic component that deflects the arising magnetic component in perpendicular ways and ends up being self-tied in an interesting knot sort of shape. But uh, I went a long way from that. So there's this displacement graph, which your river model is perfectly fine, but you could just get rid of the river entirely and consider the river bed. That if there's a potential for something to slide down, then it slides down rather than having to contend with something dragging it along. Part of my newest postulates is the no invisible hands postulate. There's no thing that reaches out and does things to something else. Matter ends up finding a gradient and evolving it into moving in that direction, which increases its velocity. So there's this displacement that pushes space away, and there's a certain radius that you can't go in. That's like a proton. This would be the displacement within a proton. Something larger would be, a proton plus a neutron. And whatever this interaction in here is, that's the resonant LC cycles. So the displacement ends up causing geodesics like this, where it's a straight line that would be to see a thing behind the sun, but ends up getting lensed around, much like this, where these lines go out and around and come back in. And they're fully continuous. Well, actually, this one isn't. You would have to be some amount of distance away in that case. But then the same retarded potentials, this is an excellent presentation that, with a spinning mass like the Earth, each particle is itself causing this displacement of space that's causing a gradient potential that's just the riverbed without any river flowing in it. And then mass outside here will find that this is a better direction to be and will migrate towards that direction itself without any external force other than this caused a displacement in space that caused a gradient that now other masses will follow towards itself. I played with cluster lensing, so this is actually an Einstein ring around this galaxy that would produce this Einstein ring shape. And This is the Abel cluster, which the background caustics doesn't actually track the um, masses when exaggerated, but these caustic layer enable. So this would cause an Einstein ring in this region and around these regions. It's really kind of I think this is pretty good. It shows, you know, the strength of the caustics around the area, and the lines are actually equi displacement curves. So those are constant accelerations. So these end up being like Lagrange points next to the masses. And then, so cluster lensing is a thing, and then fitting dark matter with a displacement curve where this is the mass profile of what's in the galaxy, and the combined outside and inside. Let me turn off, and if I just have a few masses, then this gradient outside is actually kind of shallow, whereas as I increase the number of masses, the inside becomes more dilated, but then the curvature out here ends up being sharper. And then these outside displacements also affect the inside displacements. They don't just affect what the outside is. So in the case of this, these masses are causing a displacement curve that allows this nice flat profile. And I made these nice summary graphs that are fitting my mass profile, the velocity profile, the dots of the galaxies that, you know, I match very closely. The Mond predicted lines are in purple and miss most of the time. And this is kind of their mass profile, and this is the Mond phantom mass profile, and then this is just my mass profile. But I have no extended mass beyond the galaxy. It's just what the mass is in the galaxy that causes it. That's about it. I don't know.